happy day. Today, we will be talking about quality dimensions and quality control tool. Quality, as we all understand, is a subjective term and is understood differently by different individuals. Nevertheless, it is very important when it comes to industries pertaining to manufacturing, packaging, or the service industry. In today's lecture, I will take you through the various concepts and definition of quality, quality perspectives, food quality and its attributes, quality dimensions, methods for determining the quality, and quality control tools. Some layman language of quality, as we all understand, is those means or those features of a product which meet the customer needs and thereby provide customer satisfaction. Quality means freedom from deficiencies. It is the confirmation of specification for anyone and everyone. Though it has been differently defined by theoricists in this field. Let's take up some definitions. Jain defines quality as fitness for use. An essential requirement of the product is that they meet the needs of those members of the society who will actually use them. Philip B. Crosby defines quality as conformance to requirements. Those quality parameters which fall into the acceptability range are acceptable, whereas those which do not conform to the requirements are unacceptable. W. Edwards Deming defines quality in terms of customer satisfaction and has given a multidimensional approach to defining the quality. Armand B. Flemingbaum has defined quality as a total composite of product and service characteristics pertaining to marketing, engineering, manufacturing, and maintenance, through which the product and service will meet the expectation of the consumers. Now, let's understand what is meant by quality perspectives. Perspectives from the point of view of customer or user based, perspectives on manufacturing base, on product based, and value based. When it is a customer based perspective, it is basically determines the quality of the product. The user determines the quality of the product, and very conveniently the fitness for use definition by Juran fits in here. The perspective based on the manufactured requirements is the conformance to the specifications, with the specifies product characteristics. The more closely manufacturing conforms to the requirement, the better the quality. The third perspective for quality based on the product is the features or attributes of the product that enhance the quality of the product. And last perspective is value based. Here, the element of price is introduced into the definition of quality. Quality is the degree of excellence at an acceptable price and the control of variability at an acceptable cost. Value comprises price and quality of product and service in this perspective of quality. Let's talk about the attributes of quality. There are two attributes of quality, that is intrinsic and extrinsic. As the name suggests, intrinsic attributes are those which are integral and inseparable parts of the physical product. They are based on the physical, chemical, microbial parameters and also the functional parameters of the product, including the safety, nutrition, sensory organoleptic properties, or the functional attributes. The extrinsic attributes are those which are not physical components of the product, but can be assigned after the production process. They can be defined or identified using two dimensions. First, the test or measurement indicators like quality management systems, certifications, and records. And secondly, by means of cues, including prices, brand name, manufacturing name, packaging, and warranty. Now, let's understand what is food quality. Food quality is a bundle of characteristics, objective and subjective, that satisfies the consumer requirements, and it includes nutritional quality, humanistic quality, organoleptic quality, social quality, symbolic quality, functional quality, and hygienic quality. There are 4 important properties which define the quality of the food, and they are the sensory properties, physical properties, chemical properties, and microbial properties. Within the sensory properties, we will learn about the appearance, color, texture, and flavor of the product. In the physical properties, we will learn about the size, shape, or in all, the appearance of the product. The chemical composition of the product will include the moisture content, fat content, protein, carbohydrate, vitamin and mineral content of the food, and the microbial content will include the evaluation of the presence or absence of microorganisms in the food. Let's take a look at the sensory properties in a very short manner. The color, as we all understand, one of the most important parameter that determines the quality of the food. The changes in the color are accompanied by undesirable changes in the texture, odor, or taste sometimes. For example, overaged cheese, meat, or beer might develop some of odor or color which might not be acceptable and recognized as being of poor quality to the consumers. Whereas in other cases, the color changes may not be actually detrimental, but nevertheless reduces the consumer acceptance. The second sensory property is the flavor, and one of the most important sensory parameters, which is defined by the taste and odor of the product. The food texture. As we understand, a food texture is something that we feel with our fingers, the tongue, the palate, or the teeth. All the sensation put together gives us the sensation of a food texture. Let us understand that the importance of texture in the overall acceptability of the product varies very widely depending on the kind of food. For example, the quality parameter of texture is very critical when it comes to potato chips. But it is just important as it does not contribute too much to the overall quality, but to the flavor and appearance of the food when it comes to fruits, vegetables, or bread-like products. And the same textural quality parameter might be very less important or minor importance when it comes to products like beverages or thin soups, where it makes a very negligible contribution to the overall quality. The second property based on the quality of the food product is the physical property, which includes the appearance and color. The size and shape of the product, defects and color of the food products will greatly influence the consumer's first impression about the product. Appearance factors are also useful in sizing and grading, which ensures uniformity and shortens the succeeding proceeding operations and improves the quality of the end product. Other important physical parameters which are specific to some food products like volume for baked products, textural properties for meat products, tenderness for meat, and specific gravity for liquid products. Coming to the chemical composition of the food products, the nature and amount of substances in a given food products determine the nutritive value and the other properties. We will just go through the important chemical parameters that define the quality of the food. The moisture content, removal of water from the food or binding it by increasing the amounts of salt or sugar retards many reactions and inhibits the growth of microorganisms and thus improves the quality and shelf life of the product. Also, through many physical interactions with proteins, polysaccharides, lipids and salts, water also contributes significantly to the texture of the food. The fat content in the food. The properties of the lipid such as pleasant, creamy or oily mouthful and the ability to solubilize many taste and aroma constituents of the food are of importance for food to achieve a desired texture, specific mouthfeel and aroma with satisfactory aroma retention. Carbohydrate content. The degree of ripeness, sweetness, color and firmness of the product determines the carbohydrate content and indirectly the quality of the food substances. Microbiological characteristics. Those microbes which are naturally present in the food or gets contaminated because of cross-contamination. This can be very important in determination of the shelf life and quality of the food. Now, let's have a look at what is meant by quality dimensions. Quality dimensions define the product requirements or attributes that are necessary to meet consumer expectations for product integrity. These dimensions are broadly drawn and can be applied to products as well as services. The 8 dimensions of product quality include performance, features, reliability, conformance, durability, serviceability, aesthetics, and perceived quality. We will discuss each of these in detail. There are 8 dimensions of product quality: performance, features, reliability, conformance, durability, serviceability, aesthetics, and perceived quality. Let's understand these features with suitable examples pertaining to the food industry. Performance. It refers to the primary operating characteristic of a product or service. It is usually measurable. For example, the sensory attributes, nutrition and wholesomeness of the food products. Second, features of the product. These are like bells and whistles of the product. That is, those characteristics that supplement the basic function. Additional features that enhance the products or service appeal to the consumers. For example, convenience foods. Reliability. The likelihood that a product will not fail within a specific time period. For example, the services that are guaranteed with mail delivery, certified mails, etc. In case of food service industry, consistency of sensory attributes of the foods that are being prepared are very suitable to the reliability of the product. Conformance. The precision with which the product or the service meets the specified standard. For example, concept matches. Durability measures the length of the product's life. For example, the shelf life of the product in food industry or in any other manufacturing industry. The amount of use a product can sustain before it physically deteriorates to a point where replacement is preferable to a repair. When a product can be repaired, estimating their durability is more complicated matter. Serviceability. The speed, courtesy, competence, and ease of repair define serviceability. The speed with which the product can be put into service when it breaks down, or when the competence and behavior of the service person is understood, are very suitable examples of serviceability of a product. In case of a food industry, the ease of preparation of a convenience food is a very suitable example to serviceability. Aesthetics. It is a subjective dimension indicating the kind of response a user has for a product. It represents the individual's personal preference, the ways an individual responds to the look, feel, sound, taste or smell of the food. And very precisely, sensory attributes and the packaging of the food substances fits in here as example to aesthetics. Perceived quality is also a subjective dimension. It is a quality attributed to goods or services based on indirect measures like impact of brand name, company image and advertising. For example, well-maintained tools and an immaculate workplace can indicate a good quality. We will now take the methods used to evaluate the quality. Let us now understand the methods of determining quality. There are many methods that are available to a manufacturing industry to evaluate the food samples for a given characteristic of a product. They are broadly classified into two groups, subjective methods and objective methods. Subjective methods are based on the opinions of individual evaluators or investigators as to the qualitative and qualitative values of the characteristics under study. They consist of a physiological reaction resulting from prior training experiences of the individual, the influence of personal preference, and powers of perception. They usually involve the use of various sense organs like touch, feel, smell, taste, and thereby they are also referred to as the sensory methods. Objective methods of evaluating the quality of a food. These methods consist of determinations from which the personal influences of the investigators are entirely excluded and are based on recognized standard specific test applied to the sample of the food. Thus, objective methods are those in which human element is excluded. Objective methods are further divided into three categories: physical methods, chemical methods, and microscopy methods. Physical methods are one of the quickest methods of evaluating a food product, and they do not require much training as compared to the other two methods of evaluation. The physical methods for quality evaluation of a product deal with attributes such as size, texture, color, consistency, and imperfection, or with process variables such as head space, fill weight, drained weight, vacuum in the packaging, etc. Chemical methods. Chemical methods are used for quantitative evaluations and for determination of nutritive value and qualitative levels. Chemical analysis in general are long and tedious, but some quick methods, including those for enzyme reaction rates, enzyme concentration, moisture content, total soluble solid, pH, and acidity determinants, are such which can be used quickly, and in many cases these quick tests can closely be correlated with the longer procedures with accurate value determined. Microscopy methods. Excellent application in quality control programs. It requires considerable training of a technical personnel to properly interpret the results. They are further divided into two categories: adulteration and contamination, which is used to indicate the presence of bacteria, yeast, molds, insect fragments, insect excreta, or foreign materials for that sake. Second, differentiation between cell types, tissue types, and microorganisms of various stored foods. For example, tissue testing for the stored foods in the tissues of plant materials, or microorganisms causing spoilage or undesirable fermentation changes in the perishable food products. Now, let's look at some quality control tools. The quality control tools are varied and are very important elements which helps the product or the process to be kept in control. Ishikawa's definition of quality control is the most widely used and a very broad definition which states to practice quality control is to develop, design, produce and service a quality product which is most economical, most useful and always satisfactory to the consumers. To meet this goal, everyone in the company must participate in and promote quality control, including the top executives, all divisions within the company and all employees. Let us understand what is quality control tools. Tools that help organizations to understand their processes in order to improve them are termed as quality control tools. There are 7 quality control tools. They are cause and effect diagram, check sheets, control chart, flow chart, histogram, Pareto chart and scatter diagram. We will look into these control tools one by one. Cause and effect diagram. It was devised by Dr. Koryo Ishikawa and is also known as Ishikawa's diagram after his name. A tool that shows systematic relationship between result or a symptom or an effect and its possible causes. It is an effective tool to systematically generate ideas about causes for the problems and to present these in a structured form. Now, how does a cause and effect diagram look like? It is also known as a fishbone diagram due to the shape of the complete structure. The symptom, result or effect for which one wants to find the causes are put on the right hand side, whereas the lighter boxes on the other hand, left hand side, classifies the ideas pertaining to those causes. Important subgroups in each of these main groups are represented by the middle bones, and these branch off further into subsidiary causes represented by small bones. The arrows indicate the direction of the path from the cause to the effect. They are frequently arranged into 4 most common major categories. For a manufacturing industry, manpower, methods, materials and machinery are the causes for an effect, whereas for an administration and planning industry, equipment, policies, procedures and people are commonly used. As you can see in this diagram, we have on the left hand side as the causes and on the right hand side the problem of those causes. Coming to the next tool for quality is the check sheet. These are data from a table, form, query, view or stored procedure displayed in a row or a column format. It is a systematic method of collecting, recording and presenting the relevant data in a simple manner for analysis of a process. It is important as measurement and collection of data forms the basis of any analysis. They are designed specific for the type of data to be collected and are very variedly used for data collection, monitoring the manufacturing process performance and traceability. Examples of check sheets are daily maintenance check sheets, attendance records, production logbooks. This is one such example of a quality control check sheet wherein the parameters or the errors, the reasons are written on the left hand side and the counts or check on the various dates are written on the right hand side. Control charts. Developed by Dr. Walter A. Stewart, a statistical approach to the study of manufacturing process variation for the purpose of improving the economic effectiveness of the process. These methods are based on Continuous monitoring of process variations. Control charts makes possible the diagnosis and correction of many production troubles and brings substantial improvement in the quality of the product and reduction of spoilage and rework. It tells us when to leave a process alone as well as when to take action to correct the trouble. A control chart is a graphical display of quality characteristics that can be measured or computed from a sample versus the sample number or time. The chart contains a center line that represents the average value of the quality characteristic corresponding to the in control state. The other two horizontal lines called the upper control limit UCL and the lower control limit LCL are also drawn. These control limits are chosen so that if the process is in control, nearly all of the sample points will fall between these upper control limit and the lower control limits. As long as these points plotted within the control limit, the process is assumed to be in control and no corrective action is necessary. A point that plots outside the control limit is interpreted as evidence that the process is out of control and investigation and corrective actions are required in such a case to find and eliminate the cause responsible for this behavior. These are uniformly used to present the quality of the data. They are significantly simple to interpret so that misunderstandings are avoided. They are widely used for a number of purposes. They are a proven technique for improving the productivity. They are effective tool in defect prevention. They prevent unnecessary process adjustments. They provide diagnostic information and information about process capability. A typical example of a control chart in a food industry can be that used to control the net weight or the pH of a packed product. This is a diagram which shows the center line, the control line and the upper and the lower control limits. A point falling within the upper and lower control limits will be acceptable and those falling beyond those limits will be unacceptable and needs to be corrected. The next control tool is a flow chart, and I believe this is one such control tool which is very simple and is being used by many industries to show the process flow. It is a graphical representation employing standard graphic icons, usually a series of blocks, with each block representing a major process that describes an operation that is studied or is used to plan the stages of a project. It is a very excellent tool for documentation of a process operation and is very oftenly used when examining how various steps in an operation work together. It is also important in project development and documentation. It visually records the steps, decisions and actions of any manufacturing or service operation and defines the systems, its key points, activities and role performances. In a flow diagram, the description of each of the process is written inside the blocks, whereas any other significant information is usually written outside the blocks, and each block is connected with the help of an arrow to show where that process leads to. This is a simple flow diagram showing the various process parameters and how they inculcate into the product formulation. Histograms. Histograms or frequency distribution diagrams are bar charts showing the distribution patterns of observations grouped in convenient class intervals and arranged in order of magnitude. Histograms are useful in studying the pattern of distribution and in drawing conclusion about the process based on the pattern. We can see a histogram on the slide which shows the distribution of the observations. The next control tool is a scatter diagram. This tool will help to study the relationship, whether positive or negative, between two variables is known as a scatter diagram. It consists of plotting a series of points representing several observations on a graph in which one variable is on the x-axis and the other variable is on the y-axis. The way the points lie scattered in the quadrant give a good indication of the relationship between the two variables. Also, the slope of the diagram indicates the type of relationship that exists. We can understand both these factors in the coming slide. This slide shows the relationship between the two variables x and y, and the slope also indicates the way in which they are related. The slope on the first scatter diagram, the points are scattered throughout the quadrant, and that reflects that there is a very 0 degree of relationship, correlation. There is no relationship that can be seen. The y variable is not related to the x variable. Whereas in the second quadrant we can see that most of the points lie close to each other. The relationship is positive, but a very low positive correlationship between the x and the y variable. There might be some connection between the two, but it is not very clear. The third quadrant, the points x and y lie all the more closer to each other, which indicates that there is a high degree of correlationship. The two variables are clearly related to each other. Given one, you can predict the moderate range in which the other will be found. The last quadrant, we have a perfect line of the observations which indicate a very perfect positive degree of correlation. All the points lie in one line. The variables are deterministically related, and given one, you can very precisely predict the value of the other. Coming to the last quality control tool, Pareto charts or Pareto diagrams as they are called. A tool that arranges items in the order of the magnitude of their contribution, thereby identifying a few items exerting maximum influence. The origin of the tool lies in the observation by an Italian economist, Vilfredo Pareto, that a large portion of the wealth was in the hands of few population. Pareto principle is also known as the 80-20 rule. The Pareto principle was further developed by industries who found that most of the quality problems are confined to small number of machines or workers. In other words, 80% of the problems come from 20% of the equipments or workforces. Thus, by addressing the ones causing the most difficulty, that is the 20% that is causing 80% of the problem, improvements can be made and monitored for continuous progress. It is used to continually improve the quality, whether for a product or service. Pareto charts are used to decide what steps need to be taken for quality improvement. A Pareto chart is valuable in answering many questions such as, what are the largest issues faced by a team or a business? What 20% of the sources are causing 80% of the problems? What efforts should be focused on to achieve the greatest improvements? This is a graphical representation of a Pareto chart. We can see the problems which exert the maximum influence are being positioned first, and in a decreasing order they are being listed, which is in contrast to the formulation of histograms. This gives a very clear and quick indication of those problems which exert maximum influences and thereby need to be corrected to increase the quality and productivity of the products. With this, we come to an end to this topic. We have discussed so far the various definitions and concepts of quality, quality perspectives, dimensions of quality, and the methods to evaluate quality in food substances. Also, we understood how the quality control tools can help us to maintain the quality of food products and increase the quality and quantity in production. Thank you so much.